Friends, this is question paper I, problem 1B. So what is our objective in this problem is to calculate the voltage across these 2 points. This is point X and this is point Y. Suppose I am connecting a voltmeter across these 2 points. What is the voltage measured by the voltmeter? That's a question. Suppose I am putting on voltmeter across these 2 points. What is the voltage it will measure? Right? As usual, we need to travel from X to Y. And during your journey, you may be experiencing voltage rises, you may be experiencing voltage drops, then you need to add together. That we are going to see now, right? Now, let me tell you one thing in the very beginning itself. You can take this loop, one thing, the question paper given just for confusing you, just for testing you. Here there are two resistances are there, 3 ohm and 3 ohm, both are connected in parallel. Because the current is getting divided here, again it is combined here. Both are in parallel. So therefore, before you are proceeding further, you need to simplify the given circuit, reduce these two into one. These two are in parallel. So effective resistance is 3 into 3 by 3 plus 3, that is R1 R2 by R1 plus R2. You will be getting once again 1.5. 3 3s are 9, 9 by 6 it is 1.5. Therefore, step number 1 is I am removing these two resistances to a single resistance of value 1.5 ohm. First step. Next step is, so depending on the battery, I am going to assign the polarity. You can see battery positive. So therefore, this positive is connected to this end, this positive. Then this is negative. Once again, to the battery, it is positive, this is negative. Coming down, connected to negative. So don't commit silly mistake. Sir, this is negative and this end is connected here. So this should be negative only, no? So don't take like that. Don't take like that. The polarity to be fixed by the resistance connected to the battery. Every single resistance is individually connected to the battery. You should not consider what is the polarity of nearby resistance. It is wrong. Therefore, with respect to the battery, this is plus only. So don't put minus here. In the similar manner, coming to this battery, this is positive and hence this is positive. This is negative. Coming down again, this is positive, this is negative. So negative is going here. Clear? So what you need to do? Again I am repeating. Battery terminal positive. Lengthy line means positive terminal. Positive to positive resistance. Then this must be negative. One end positive means another end negative. Which implies current is entering at one end, leaving at other end. One is positive, another is negative. Then with respect to battery, this is positive, this is negative. Similarly here, battery positive, resistance positive, negative. Then battery positive, resistance positive, right? Negative connected to battery. Wow. Now, in this problem, one interesting point is there to share. Even in the last problem, what we did, we had calculated this loop current, everything. But the question given here is to find Vxy. If you are choosing one particular path, you can directly write your answer, for which they are giving 8 marks. If you can directly calculate your answer without doing any computations, any current calculations. Let me tell you how. I am starting my journey here. I can put some letters here, say A, B, C, D, E, F. Some letters, you can put anything, right? So, I am starting from X. I am going to use the path X to C, C to D, D to Y. If I am using this path, my dear friends, you can see there is no resistance at all. There is no resistance at all. X to C, a line. C to D, only the battery. D to Y, again only the battery. Therefore, readily we can see one thing. Therefore, Vxy is equal to, from here to here, there is no resistance, there is no voltage drop, there is no voltage rise. Therefore, the contribution of this portion is 0 because there is no resistance. A voltage drop or rise is possible one and only if there is a resistance is present, right? So here it is 0. I have reached here. Then I am traveling here. For this battery, when I am traveling here, I am touching the negative terminal first. See here. I am starting from C. I am going to D. So during that journey, I am touching the negative terminal here. Therefore, since I am touching the negative terminal of the battery, that voltage should be taken as positive. Right? So this is plus 8. Suppose if this polarity is ulta, something like this, then when I am traveling from C to D, I am touching the positive terminal first. Therefore, this will become minus 8. But that is not the case here. I am just going back to the original thing. This is negative and this one is positive. Originally given in the question paper. So this is 8 volts. Now I have reached D. Started from X. During X to C, there is no resistance, voltage is 0. During C to D, this is considered. Then from D to Y, again I am traveling, I am touching negative terminal, so that will become plus 6. With once I am crossing this battery, I have reached Y, so my work is over, 14 volts. My dear friends, without calculating any current or any other computation, directly by choosing the path X, C, D, Y, you can get your answer. But yesterday I told you, you can use even alternate path and you will be getting the same answer. I want to check whether it is correct or not, right? So for example, in this case, instead of using this path, I am traveling from X to A to B, B to C, C to D, D to E to F and F to Y. See how lengthy path that I am choosing. Instead of, this is one calculation. I am using the path X, A, B, C, D, E, F and finally Y. X, A, B, C, D, E, F, Y. In this case also, I must need to end up with 14 volts, which we got already. Let us see. But in this case, the calculation will be a bit lengthy. Why? Because we need to come across so many resistances. Therefore, because even though it is not useful for this problem, in the coming problems or in the examination, if they are giving some other problem, you may have to go for these calculations and all. Therefore, I am explaining this one. Right? Now, in this problem, since in this route, since there are some resistances are there, first step is calculate loop 1 current and loop 2 current. As I told you, since both the loops are independent, there is no current flow here. Yesterday that's have been sufficiently discussed. This loop is separate, that loop is separate. This is separate, this is separate. Because now you kindly listen. Suppose if this B and D is connected, what will happen? There will be a current flow here. If there is a current flow, then obviously these two are depending and this current will be flowing here also. Everything will be combined. Therefore, you cannot adapt to Ohm's law. Right? Luckily, this connection is not there. This connection is not there. And hence, only a branch is there. There is no loop. I am repeatedly telling, if you want to apply KVL, mere branch is not sufficient. You need a loop. You need a loop. In this case, there is no loop, only the branch, and hence this loop separate, that loop separate. You can easily apply Ohm's law for the first loop. In first loop, current I1 is equal to voltage, which is equal to voltage is 5. Resistance is 2 plus 3, which is equal to again 5. 1 amps. Similarly, coming to this loop, I2 equal to V by R. V is 6 by 1.5 plus 1.5, 3. Two amps. Here also if you want I can write in this way. 2 amps. So first loop current is 1 amp, second loop current is 2 amps. Now everything is over. Come to this. When therefore Vxy is equal to, I am started from x, moving towards A. I need to go moving towards A. When I am traveling from x to A, which terminal I am touching first? You tell me which terminal I am touching first? I am touching negative terminal. I am starting from x, traveling to A. Which terminal I am touching first? Negative. Therefore, take this value as plus 5. This is over. Now you are in A. A to B I need to go. A to B I need to go. When you are traveling, you are touching the positive. So, whatever the value you are going to get, that will be negative. Because from here to here, you are going to travel here. You are touching positive, it is going to be negative minus, what is the voltage across to? Because every time I need voltage. Correct? Voltage, what is the voltage here? This voltage equal to 2 into, what is the loop current? 1. Artha madkoli. What is this entire thing? Why I am putting minus? I have right now in A, I need to go to B. When I am traveling from A to B, I am touching the positive terminal here, therefore a negative side. Next, I need a voltage across this 2 ohm resistance. Voltage V is equal to I into R. R is 2, I is 1. Therefore, it is 2 volts. So, this is over. A to B is over. Then B to C. Again, from B to C, I am touching the positive terminal. So, that will be negative. 3 into 1. 3 is the resistance, 1 is the current. Right now you are here. B to C is over. You are reached here. Started from X, X to A to B, B to C. Then C to D, as usual the same value, plus 8. Then D to E. D to E, when you are going, you are here, you need to go to E. When you are coming down, you are touching negative terminal first. So, plus 1.5 is the value of resistance, 2 is the current, multiply these two. 1.5 into 2. You are reached here. What is E to F? D to E is over. What is E to F? E to F, no resistance, so therefore plus 0. Then this is over. F to Y. F to Y, you are touching negative first. You are touching negative, so that will be positive 1.5 into 2. Reducing everything, 5 minus 2 minus 3 plus 8 plus 3 plus 3. So adding together 6, 14, 19, 19 minus 5, 14. As in the case. So what is the message I want to convey here is, if you want to calculate any potential difference between any 2 points, you need to travel. Travel from one point to another point. During your travel, there will be rise, there will be drop. Rise means plus, drop means minus. Finally, you need to add together to get the voltage. And during your journey, you can follow any route, you will be getting the same answer. So, this is how this problem to be solved. And any queries, please? Fine. Thank you.